Hello everyone, welcome back to this tutorial series on the theory of computation. In this video, we'll be starting our discussion of the regular expressions. So the regular expressions are essentially another paradigm that we'll see can be used to prove that a language is regular, okay? But what you need to know right now is what a regular expression actually does, okay? So what does a regular expression do? Okay, well, in a few words, essentially the role of a regular expression is to describe a language. So the way that I think about it is you can have the set of all the regular expressions that could be possibly written in the world in some set, right? So you have the family of all the regular expressions. So you have maybe one regular expression here, I'll denote it by R1, just because it starts with R, so I'll use R as the regular expression. You have the regular expression R3, R4, and so on, right? So, like you'll see in a second, there's an infinite number of regular expressions, just like there were an infinite number of finite automata, and each of these regular expressions denote a particular language. So they denote or they describe a particular language. So if we have another set, okay, or another family, so this is the family of regular expressions, and this is the family of languages, which in subsequent videos we'll see is a family of regular languages, but this will be soon, not quite right now. Right now, I'm just trying to explain to you what a regular expression is, okay? So regular expression is just meant to be a way of compactly describing a particular language. So some particular language, maybe this is the language L1, okay? So it's similar to how you have the definition of something mapping to a particular object. When you have a regular expression, when you write down a regular expression, you're mapping what this regular expression is to a single language, okay? And that's essentially the idea behind the regular expression. So it's unlike an FA where it does not accept strings. It does not accept or reject strings, okay? So regular expressions have no transition functions. They have no mechanisms where they take a string and they output something. So in an FA, right, in an FA, you would give an FA a string and then it would output yes or no. So this is not what a regular expression does, okay? It's also unlike a grammar, okay? So it's unlike a grammar. So maybe some of you don't quite know what a grammar is yet, okay? Maybe some of you do. But essentially, a grammar is some mathematical object that is meant to generate strings, okay? And so that's something that people often get wrong, is they think that a regular expression generates strings, okay? You can think of it that way when you're trying to write out a regular expression just to help you sort of intuitively. But that's not what a regular expression does. It has no mechanism for creating new strings. What it does is that once you write down the regular expression, you instantiate this mapping, right? This pointing to a particular language. And so unlike a grammar, it does not generate strings. So In grammars, and we'll definitely see examples of grammars later on, in grammars, you have a set grammar, and the grammar just generates strings. So W2, W3, and so on. And so this is not what a regular expression does. So in neither of those cases, neither of these two cases, is there a behavior akin to what the regular expressions do. Okay? Okay, so this is the general picture of what I want you to have when I'm going to be introducing regular expressions. So you really have to think of them as being these potentially more compact representations of particular languages. Okay? Okay, now, how do we actually define a regular expression? What makes a regular expression a regular expression? Well, we have a concrete definition here. So, given an alphabet sigma, so suppose sigma is AB, we can define rules for identifying valid regular expressions. Okay? And this definition is actually recursive. So it's a recursive definition because you can build valid regular expressions from smaller valid regular expressions. Okay? And the smallest regular expressions are the primitive regular expressions, which look like something else, but you have to distinguish them from what they seem to look like. Okay, so what do I mean by that? You can have the regular expression that looks like the empty set, okay, but note this is not the type of phi in this case. Let's just call it phi, right? Is not a set, okay? It's a regular expression. Okay, this regular expression, okay, so if we have the set of regular expressions, this regular expression maps to a language, which just so happens to be the empty set. Okay, but you have to be very careful when you talk about these things. Here I'm introducing this new notation or this new mathematical object where this symbol here represents a regular expression known as the empty set regular expression. Then we have the empty string regular expression. So this is the empty string regular expression. And then we have the letter regular expressions. Letter regular expressions. Okay. And now, based on these primitive regular expressions, we can build up more complex regular expressions. And the operations that are used to build up these more complex regular expressions are the plus operator, the dot operator, the star operator, and also parentheses. These aren't necessarily required, they just help with notation. So these are just to disambiguate notation. Okay? But these are the operators. These are the operators that combine regular expressions to build up more complex regular expressions. So for example here, I have this sequence of symbols, right, which happens to be a valid regular expression. Why is it a valid regular expression? Because I can identify primitives, right? So I have these symbols which represent the primitive regular expressions, and then they've been joined together with the three operators, okay, that combine regular expressions. So here, this is akin to the concatenation, the string concatenation. It's not string concatenation, it's the concatenation operator for regular expressions, right? Which creates the regular expression BA. We have the empty set star, which is another regular expression. We have A plus the empty set, where when I said A and the when I said a in the empty string, I meant these as regular expressions, okay? And we've built all of these guys up together to create this whole more complex regular expression. An example of something that is not a valid regular expression is something like this, right? So here, yes, we have valid primitives, but now we've kind of augmented them with invalid operators. So for some reason, there's an intersection here, right? So this is a mistake that people often make, right? So these two are regular expressions. You cannot intersect regular expressions. You can only intersect the languages that they describe, right? So the intersection is a language operation. So you can only intersect the languages they describe, okay? And there's some other invalid operators like the minus sign here and the reversal operator. These aren't valid for regular expressions, okay? It could be that you could define a new operator, right? But from the basic definition of regular expressions, this thing that I just wrote down is not a valid regular expression, okay? So now, like I said before, regular expressions, the role is to point to a particular language. So how do they actually do that? How do you determine, right? So how do you determine the language pointed by the regular expression? And that's what we're going to do in the next slide, okay? And the way you can do this is also kind of in a recursive manner. So we have the languages denoted by the primitive regular expressions. So these are the languages denoted by the primitives. So for the regular expression denoted by the empty set, right? Or sorry, for the regular expression which has the symbol the empty set, the language described by this regular expression is the empty set, okay? So the way you read this, right, the way you read this is L of R is the language denoted by R is, and if it's equal to L, is L. So here the language denoted by this guy as the regular expression is this guy as the set, okay? So this symbol represents different ideas when their types are different, right? So this is the symbol empty, let's just call it the symbol empty, with type set, and this is the symbol empty with type regular expression, okay? Then the similar idea applies to lambda, right? So L of lambda, when this is of type regular expression, denotes the set containing the empty string, okay? And then for L of a single letter, right? A single letter or symbol where the type of that letter or symbol in this, between these two brackets, is a regular expression. So what it actually maps to is the language containing that letter, okay? And then lastly, we can combine the primitives into the same way that we can combine the primitive regular expressions into more complex regular expressions. We can do the same thing for the languages that they denote. So if we have two regular expressions, R1 and R2, and we've combined them with the plus operator, then this means that the language that's denoted by this regular expression is the union of the language denoted by R1 with the language denoted by R2. Okay, so all of this expression has type regular expression, and now the right-hand side has type set. So it has type set. So now this is a language containing strings. Okay. Furthermore, now if we have R1 concatenation operator R2 for regular expressions, right? Then the language denoted by this regular expression is the concatenation of the languages denoted by each regular expression, right? So here, this dot is a regular expression operator, and here this dot is a language operator, okay? And lastly, with the star operator, when you apply the star operator to a regular expression, the language that's denoted by this new regular expression is the star operator applied to L of R1. So the language denoted by the regular expression R1. Okay, so this is a quick intro into what languages denoted by regular expressions are, how we can build more intricate regular expressions. In subsequent videos, we'll be looking at examples of exactly determining what the languages are that are denoted by these regular expressions, and also building or creating regular expressions to denote specific languages.